The other type of Friedel-Crafts reaction is Friedel-Crafts acylation. In Friedel-Crafts acylation, you start with a benzene. Instead of starting with an alkyl halide, you start with an acyl halide. The acyl is simply an R connected to a carbonyl in there. And you're going to use the same catalyst as you used before. So the reaction starts by the reaction of the acyl halide with the catalyst. And you're going to form the electrophile. The electrophile here is the acylium ion. So here you are forming the acylium ion. So you can see there is no direct carbocation that is formed. It's just the positive charge on the carbonyl. This means that in this reaction, there is no rearrangement. Whatever I start with, I end up with. So here I am creating a bond between the carbon of the benzene and the carbon of the carbonyl. And this is the new bond that I am making in there. This reaction is more favorable than the Friedel-Crafts alkylation because there is no rearrangement in this one. So let's have an example over here. Starting with benzene, reacting it with the acyl chloride in presence of AlCl3. So start your reaction first by reacting those two reagents together in order to get the acylium ion. It's a Lewis base, Lewis acid reaction. And the Lewis acid reaction in there, electrons go from the base to the electrophilic site of the aluminum, and you're going to make a complex. The moment you make a complex in there, this is going to be a very good leaving group in here. So immediately this is going to leave, and you're going to create the acylium ion. When the plus charge is on the carbonyl, we call this an acylium ion. This acylium ion is stable because you can do resonance. It's stabilized by resonance, but no need for you to do the resonance in there. Just work with the acylium ion and take that acylium ion, carry it to the next step of the reaction. Your conjugate base, we're going to use it to regain the aromaticity of the benzene as usual. So that acylium ion is going to be the electrophile. We're going to use that, react it with the benzene in a two-step reaction, and you are going to end up getting your product. So in order to figure out the product without the mechanism, simply locate where is your carbonyl together with the R, and it's that carbonyl that is going to make a bond with the benzene. Make sure that the benzene stays aromatic because this is going to be our product in this case, and make a bond. So this is the new bond that I made between the carbonyl and the benzene, and then add whatever R there is next to the carbonyl. Just go ahead and add it. Since here I have a benzene, so you go ahead and you add the benzene. We said the Friedel-Crafts acylation is more useful because there is no rearrangement. What makes it also more useful is the carbonyl that you form in the product. You can also reduce it into a CH2. So that carbonyl can undergo reduction into a CH2 by two different ways. Either you can use a Clemmensen reaction, or you can use a Wolff-Kishner reaction. Wolff-Kishner reaction involves the use of a base together with hydrazine. Hydrazine is NH2, NH2, and heat. The other type of reduction reagent is using an acid and zinc wrapped in mercury. You are responsible to know both of these reagents and both names of these reagents. So any carbonyl in the reactant can get reduced, and it can get reduced into a CH2. Here I am not adding a carbon. I am actually taking away an oxygen and adding two hydrogens. So this is the carbon over here where I'm doing the reaction on. It stays. But now instead of the oxygen, I added two hydrogens in there. So simply the carbonyl is going to turn into a CH2. no addition of carbons, just taking away the double bond and the oxygen and replacing those with two hydrogens in there. Both reagents will do exactly the same thing. The good thing about this reaction is that I can carry out the Friedel-Crafts acylation, get my carbonyl in there, and then reduce that carbonyl into a CH2 in case I wanted to add an odd group and I didn't want to do any rearrangement with Friedel-Crafts. Same thing over here, because it's impossible with Friedel-Crafts to add that butyl group without rearrangement. So I carry it with Friedel-Crafts and then I reduce that carbonyl into a CH2. In this case, I would move from an electron withdrawing group to an electron donating group on the benzene. We said that an electron withdrawing group is a group that has a partial positive charge directly connected to the benzene. And here the carbonyl has a partial positive charge because of the oxygen. The oxygen is an electronegative element, so that oxygen is going to pull electrons away from the carbon. And when it does, it's going to end up having the carbon being partial positive and the oxygen here being partial negative. So that carbon, because it's partial positive and directly connected to the benzene, we consider this whole group now to be an electron withdrawing group. On the other hand, if we have a benzene and we have an R group, which is a carbon, this is an sp3 hybrid carbon that is connected to the benzene. So this sp3 hybrid carbon is connected to the benzene. Now this carbon of the benzene is an sp2 hybridization. And we know that sp2 carbons, they are more electronegative than the sp3 carbons. Okay, so if you look at the direction of polarization now, it's going to be from the sp3 to the sp2. The sp2 is more electronegative. It's going to pull electrons towards the benzene. So that is going to make this carbon over here an electron donating group to the benzene. And it's donating electrons through the sigma bond by inductive effect. So with these reactions, I can simply change the identity of the group that is connected to the benzene from an electron withdrawing group to an electron donating group by doing a simple reduction reaction. Friedel-Crafts has limitations, means that the reaction stops whenever you have these conditions in there. If you have a benzene and on the benzene you have any electron withdrawing a group, then in this case there will be no Friedel-Crafts alkylation, no Friedel-Crafts acylation. So we defined an electron withdrawing group. It's a group that takes electrons away from the benzene, meaning that the group needs to be either partial positive, like in the case of the cyanide, like in the case of the carbonyl, in there. The sulfur here, this is partial positive. So any partial positive element, whether it's a carbon, whether it's a sulfur, it really doesn't matter, or a solid positive charge element, like for example here, the nitrogen, this is a negative charge. If this is connected to the benzene, then this is going to be called an electron withdrawing group. I will give you a table with electron withdrawing group and electron donating groups. You don't need to memorize those groups in there. You can get those in the exam. So any electron withdrawing group on the benzene will end up not having a reaction with Friedel-Crafts acylation or alkylation. Friedel-Crafts also doesn't work if I start with phenols or if I start with aniline. OH and NH2, these are not electron withdrawing groups. These have lone pairs. And because they have lone pairs, these are considered to be strong electron donating groups. We said that whenever you have a group on the benzene that has lone pairs, then this group is going to donate electrons to the benzene. And the donation of electrons is going to be by resonance. So OH and NH2, both of these are strong electron donating groups. When you're doing a Friedel-Crafts reaction with those, because they are very strong electron donating groups, and they are very strong nucleophiles. So here, the oxygen already has electrons. So if you're doing any Friedel-Crafts alkylation or acylation, before even creating your electrophile. So before the alkyl halide or the acyl chloride reacts with the aluminum chloride, since the oxygen and the nitrogen, they both have electrons, immediately there will be a reaction between this oxygen that will be considered a Lewis base and the aluminum that will be considered a Lewis acid. This alone will stop the reaction immediately, because you will create a complex in there, and that complex will stop the reaction and will prevent any of those two reagents to react with the aluminum chloride and get the electrophile that we need for the electrophilic aromatic substitution. So same thing over here. The first step, the nitrogen now is going to make a complex with the aluminum. The nitrogen will behave as a Lewis base. The aluminum is going to behave as a Lewis acid, and you are going to get a complex in there. That complex is going to introduce a plus charge on the benzene. So that group now is going to be a deactivating or an electron withdrawing group. Deactivating is another word for an electron withdrawing group that is going to stop the reaction. So this, with any of the reagents of the Friedel-Crafts alkylation or acylation, will have no reaction because already you have an electron withdrawing group on the benzene. Same thing over here, that oxygen, since it's a plus charge, it will be an electron withdrawing group. So if you are reacting it with Friedel-Crafts alkylation or acylation, there will be no reaction. So to sum up the limitations of the Friedel-Crafts reaction, if you start with a benzene, and if on the benzene there is any electron withdrawing group with Friedel-Crafts, acylation, or alkylation, there will be no reaction. Also, if you start with a benzene, and on the benzene, there is just an OH in there, not any other group, just the OH in there. So it needs to be a phenol, a mono-substituted phenol. So there should be no other substituents on the benzene. If there are other substituents on the benzene, Friedel-Crafts will happen. We will consider this case as we go. What if it's just phenol in there, and you are doing Friedel-Crafts acylation or alkylation, then there will be no reaction. Same thing if you are starting with aniline, and these are the only two electron donating groups that do not undergo Friedel-Crafts reaction. So again, Friedel-Crafts acylation or alkylation, then there will be no reaction. Other than that, if you are starting with a benzene and any other electron donating group, doesn't matter what that is, but any other electron donating group other than the OH or the NH2, then there will be a reaction with Friedel-Crafts reaction. So there is a Friedel-Crafts reaction, Friedel-Crafts acylation and alkylation.